Okay, this lecture video is continuing on graphing quadratic functions. And this time we're going to look at standard form of a quadratic function. Standard form of quadratic function is f of x equals ax squared plus bx plus b. In the last video we looked at the vertex form, which is f of x equals a times the quantity x minus h squared plus k, where the vertex was at the point hk. The a in this formula and the a in this formula are the same number. So this a also depicts whether this quadratic function is going to be opening up or down. So down here, if a is greater than 0, this parabola or quadratic function will open up. If it's less than 0, then it will open down. So it will look like this if a is bigger than 0. It will look like this if a is less than 0. The other thing that we're going to look at this time are X-Intercepts. To find X-Intercepts, you set the function, or this part of the equation, equal to 0, and then you solve for x. And that will find your X-Intercepts, or this is the places where this graph will cross the x-axis. Like in the same way, Y-intercepts are places where the graph will cross the y-axis. And you find those by plugging 0 into the function, so you find the value f of 0. And then the other thing that we didn't talk about yet was the vertex. When you have standard form of the vertex, then the x-coordinate of the vertex is at the value negative b over 2a. And then you take that number that you get for x and you plug it into the function to figure out what y is. So let's take a look at how to use this formula. And we're going to do the same thing as we did before. We're going to find the vertex. We're going to look at our value of a, and then you can use that pattern that we talked about last time, where you move right one, and then you go up by a. Well, let's write this the other way around. Up a, and then right one again, and then you go up 3 times a. And then you do the pattern the same way on the other side. So we saw that last time. So our first example, we have f of x equals x squared plus 6x plus 9. So the first thing that we want to do is look at a. A for this one is equal to 1, which is greater than 0. So this opens up. And then we want to find our x and y intercepts. So x-intercepts is setting the function equal to 0. So f of x equals 0. So you're going to take x squared plus 6x plus 9 and set it equal to 0. And then solve for x. So this one actually factors. It factors as x plus 3 times x plus 3. And so we get x is equal to negative 3. When you set x plus 3 equal to 0, you get x equals negative 3. And you'll get the same number when you set this x plus 3 equal to 0. So there's only one x-intercept here. It's negative 3. And then we need to find our y-intercepts. And you should only get 1 when you do this. So this is finding f of 0. So we want to plug 0 into our function, and we'll get 0 squared plus 6 times 0 plus 9, and so we get 0 plus 9, which is 9. And when you have it in standard form, whoops, I didn't mean to draw through that, these first two terms will always be 0, the ones that contain an x, and so you'll always just end up with this constant, whatever it happens to be. I need to scroll up so we have some more room to do some work, because we need to find the vertex for this. So I'm going to move away from this, so you probably won't be able to see the formula anymore, but I'll write it down here. So we had f of x equals x squared plus 6x plus 9. And so we need to find our vertex. And the way that we find the vertex, remember, the x-coordinate was at negative b over 2a. And so put your negative sign down, this negative sign right here, and then it's b. b is always the number that's right in front of x. So for this one, it's positive 6 divided by 2 times a, and a is always the number right in front of x squared. And when there is no number there, there's an implied 1. So a for this one is 1. And so we end up with negative 3. Now to find the y-coordinate, you just plug this into your function. So we want to find f of negative 3, which means that we're going to replace the x in our equation, x squared plus 6x plus 9, with a negative 3. So that'll be negative 3 squared. And I'm just going to erase this for a minute. If you're new to plugging things into a function, it's nice to what I call writing the shell of the function down. So we have x squared, so we're going to do a parenthesis squared plus 6, and then a parenthesis for the x, and then plus 9, and you put in the parenthesis the number that you need to replace x with. So we're going to put a negative 3 in there. And it's just important, especially if you're going to use your calculator to do this, to make sure that you put this number in parentheses, because writing negative 3 squared this way and writing negative 3 squared this way are different things. This gives you negative 9, but this gives you, when you have the parentheses, positive 9, because this is the same as doing a negative 1 times 3 times 3, whereas this is negative 3 times negative 3. So that's the difference between that notation. So just be careful of that. Okay, so when we do our calculation for the y-coordinate now, we're going to get positive 9. And then we have plus 6 times negative 3, so that's plus a negative 18. And then plus 9. So 9 and 9 is 18, and then a negative 18 gives you 0. So our vertex is at the point negative 3, 0. And I'm just going to switch back to my black pen here. Scroll back up. So our vertex was at negative 3, 0. And it's opening up. And this was also our X-intercept. So this vertex, it is just sitting right on the x-axis here. And then we want to go right 1 and up 1, and then right 1 and up 3, left 1 up 1, and left 1 up 3. The other point that we do have to make sure we plot is our y-intercept, which is at 9 up here. So when you're asked to find your intercepts, you need to make sure that you're plotting those. Let me draw this in a little bit better. And label the rest of my points. So I have negative 2, 1, negative 1, 4, 0, 9. That was my y-intercept. And then over here I have negative 4, 1, and negative 5, 4. And so there is our parabola. And the domain, all parabolas have a domain of negative infinity to infinity. And the range is from the vertex on up when they're opening up. So that's going to be from 0 to positive infinity. Okay, let's take a look at our next example. Our next example here is f of x equals negative 2x squared plus 4x plus 6. So a for this one is negative 2, always the number in front of your x squared there. This is less than 0, so it's opening down. And then we want to find our x-intercepts. X-intercepts happen when the function or the y values are 0, so we want to set this function equal to 0. And so that's taking this whole thing and setting it equal to 0. So negative 2x squared plus 4x plus 6 equals 0. And we want to see if we can factor this and solve for x. And so I'm going to factor out a negative 2 because I like my x squared to be positive. So that'll give me negative 2 times the quantity x squared minus 2x minus 3 equals 0. And then we can factor what's inside the parentheses there. So I have my negative 2 and this will factor as x minus 3 times x plus 1. You want to factor negative 3 so that the sum of those factors gives you negative 2. And negative 3 times positive 1 gives us the negative 3, and they add up to give us the negative 2. So this doesn't give us anything as far as x-intercepts are concerned, this negative 2, but we set the x minus 3 equal to 0, and we get x equals 3, and then set x plus 1 equal to 0, and we get x equals negative 1. So we have two x-intercepts. One is at 3, 0, and the other one is at negative 1, 0. Now we want to find our y-intercepts. Y-intercepts happen at f of 0, so we want to plug 0 into our function. And again, let me scroll back up so that you can see this equation. This term will become 0, this term will become 0, and it'll just be left with positive 6. So 6 is going to be our y-intercept, so that's 0.06. And now I'm going to scroll down, so we're not going to be able to see the equation, but I'll write it down. So we have f of x equals negative 2x squared plus 4x plus 6. This was our original equation. And the x-coordinate of our vertex is at negative b over 2a. So bring this negative sign out, and then we want b. b is always going to be your number right in front of x, so that's going to be 4. And then divided by 2 times a, and a is always the number in front of x squared, so that's a negative 2. So we have a negative 4 divided by negative 4, which is positive 1. Next, we want to take this 1 and plug it into our function, so we want to find f of 1. And again, I'm going to write the shell of my function down, so that's negative 2. And then we have x squared, so I want a parenthesis squared, plus 4 times a parenthesis, because we have 4x, and then plus 6. And the value that we're putting into x is 1. So we have 1 squared is 1 times negative 2 gives us negative 2, plus 4 plus 6. So this is the plus 4, and here's the plus 6. And so we have 10 minus 2, which is 8. And so our vertex is at the point 1, 8. Okay, so let's put all this information on our graph. So we have our vertex at the point 1, 8. It's opening down. And we can use our pattern to get some more points. So we can go right 1, down 2, because you go right 1, down a, and then right 1 again, and then down 3 times a, which will be 6. So there's 2, 4, 6 will put us right there, and then left 1, down 2, and then left 1, down 6. And this pattern actually hit all of our intercepts already, so those are already all on our graph. Now I'm going to draw in my graph, labeling my points, 2, 6, and this is the point 0, 3, and this is negative 1, 0. Oops, sorry, I labeled that backwards. That should be 3, 0, and this is 0, 6. And our domain is negative infinity to infinity, and the range, so this one's opening down, so it's starting down at negative infinity, and it stops up here at 8. And we use a square bracket because it's including that point there. Our next example, we have f of x equals x squared plus x plus 6. So again, we want to look at a. A for this one is equal to 1, so that tells me that it's opening up. And we want to find our x-intercepts. X-intercepts happen when our function is equal to 0. So we want to set x squared plus x plus 6 equal to 0. And see if we can factor this. So we need to factor 6 so that the sum would give us 1. And we can do that. Well, no, sorry, we can't. So So 2 and 3 would negative 2 and positive 3. These sum to give us the 1 that we need, but they don't multiply to give us positive 6. They multiply to give us negative 6. So this one won't factor, and when a quadratic doesn't factor, that means that we need to use the quadratic formula to figure this out. So quadratic formula was negative b plus or minus the square root of b squared minus 4ac. And it's all gets divided by 2 times a. So negative b is going to be negative 1 plus or minus the square root of b squared, so that'll be 1 squared, minus 4 times a, which is 1, and then times c, which is 6. And this all gets divided by 2 times a, and a for us is 1 this time. So we have negative 1 plus or minus the square root of 1, 1 squared is 1, and then minus 24. All over 2 times a, which is 1. So we get 2 in the denominator. So that's negative 1 plus or minus the square root of negative 23. So 1 minus 24 is negative 23. And this is not a real number. And so when you get a negative number underneath a square root like this, what it means is that there are no x-intercepts. So this graph never crosses the x-axis, and you could have gotten that because this is opening up, and when we find our vertex, the vertex will be above the x-axis. So, and then our y-intercepts. Let me just write this equation down again. X squared plus 6x, x squared plus x plus 6. That's our function. And so when we plug 0 into this, f of 0 will give us 6. So our y-intercept is at the point 0.06. And then we also need to find our vertex. And the vertex, the x-coordinate is at negative b over 2a. So write your negative sign down. B for this one is 1. And then times 2 times a, and a is also 1. And so we get negative 1/2 as our x-coordinate. Then to find our y-coordinate, we want to just take this negative 1/2 and plug it into our function. So that's negative 1/2 squared minus 1/2 plus 6. So again, if you're plugging this into your calculator, make sure that you include the parentheses around that negative 1/2 so that you get the right value. So negative 1/2 squared is a positive 1/4, and then we have minus 1/2 and plus 6. I need to find a common denominator, and the common denominator is going to be 4. So we have 4, 2, and this would be 6 over 1. And negative 1/2 is the same as negative 2/4. Plus, multiply the numerator and denominator of this one by 4, and we get 24/4. So 1/4 minus 2/4 is negative 1/4, and negative 1/4 plus 24/4 is 23/4. So our vertex is at the point negative 1/2. Or we'll do this in decimal form. Sometimes that's a little bit more meaningful. So that's negative 0.5, and then 23/4 as a decimal is 5 3/4, so that would be 5.75. Okay, so let's put our information on our graphs. We have negative 1/2 and 5.75 as our vertex. So here's negative 1/2, and then we want to go up to 5 3/4. That's about right there, and we're opening up. And we could use the pattern on this, but I find when we have these decimal vertexes, it's a little bit cumbersome to use the pattern, and so to get the 4 other points, we'll use our intercepts. So we don't have any x-intercepts. Remember, this vertex is above the x-axis and we're opening up, so it will never cross our x-axis. But we do have a y-intercept. That was at the point 0, 6. The nice thing about parabolas is that they do have symmetry that we can work with, and so this is symmetric about the line that passes through the vertex here, and so we can get another point by translating this over to the other side of the vertex. So this is 1/2 units away from the vertex, so go 1/2 units the other way, and it's 6, and that will give you another point. So at -1, 6, we have another point. And then we need 2 other points on this graph, and so I'm going to plug 1 into our function. So I'm going to plot 1 point, and so I'm going to find f of 1. That would be 1 squared plus 1 plus 6, which gives me 1 plus 1 plus 6, or 8. So I have the point 1, 8 on the graph. And again, you can use the symmetry of this to get another point. So this is 1.5 units away from the vertex, and so we want to go 1.5 units the other direction from the vertex to get another point. So we have a point at 1, 8, and then we also have a point at -2, 8. Then you can draw in your parabola and do our domain and range. Domain is -infinity to infinity. And the range, because this one is opening up, it will go from the vertex up to +infinity. And our vertex was at 5.75, and that'll go up to +infinity. And our next example here, f of x equals x squared plus 5x plus 1. So again, a for this one is 1, which is greater than 0, so it's opening up. And then we want to find our x-intercepts. X-intercepts happen when y is equal to 0, so we want to take x squared plus 5x plus 4 and set it equal to 0. And this one does factor. We want to factor 4, so the sum gives us 5, so that would be +1 and a +4. So when you set x plus 1 equal to 0, you get x equals -1, and when you set x plus 4 equal to 0, you get -4. So our x-intercepts are -1, 0 and -4, 0. And our y-intercepts, that happens when we plug 0 into our function, and again, both of these terms become 0, so we're just going to be left with 4. So that gives me the y-intercept 0, 4. So now I'm going to scroll down, I'll write our function back down, so that was f of x equals x squared plus 5x plus 4, and we need to calculate our vertex. The x-coordinate of our vertex, again, is at -b/2a, so that's a negative. Our b is the number right in front of x, so that's 5. And then 2 times a, and our a is 1, the number right in front of x squared. So we get -5/2 is the x-coordinate of our vertex. And then we need to find the y-coordinate of our vertex. And so that's taking this number, -5/2, and plugging it into our function. So again, I'll write the shell of the function down. So that's the x being squared, and then 5 times the x, and then plus 4, and then put inside the parentheses your -5/2. So -5/2 squared is +25/4, and 5 times -5/2 is -25/2. And then we have plus 4. We need a common denominator, And we can think of 4 as being 4 over 1, so we have a 4, a 2, and a 1, so our common denominator is going to be 4 here. So we don't have to do anything with our first fraction. This fraction we have to multiply both the numerator and denominator by 2 to get the 4 in the denominator, and so that would be negative 50. And then we have 4 over 1, and we need to multiply both top and bottom by 4, and so that's going to be 16/4. So 25/4 minus 50/4 is negative 25/4 plus 16/4, and that gives us negative 9/4. And so that's negative 2.25. So this vertex is at the point, and I'll write this as a decimal as well, so that would be negative 2.5 and negative 2.25. So now let's put all of this information onto our graph. Our vertex is at negative 2.5 and negative 2 1/4. That would be, oops, that's negative 1 1/4. Out right there. And this one is opening up, so we have negative 2.5 and negative 2.25. And then, again, this has got all these crazy decimals in it, so using the pattern is going to be a little bit tricky, so I'll just put the rest of our information on there. We have a y-intercept at 0.4, and so that will give us another point, and then we also have our x-intercepts, one at negative 1, 0 right here, and the other one is at negative 4, 0 right here. And our intercept is at negative 2.5, so it's right there, and so this point right here is 2.5 units away from our vertex, and so we can go 2.5 units this direction to get another point, and at the same y value as this y-intercept here. And so that gives me, oops, that gives me the point negative 5, 4. Now we can draw in our parabola and our domain, negative infinity to infinity, just like with all the other parabolas, and then the range, because it's opening up, goes from the vertex on up. So the y-coordinate of the vertex for this one is negative 2.25, and it goes up to positive infinity. Okay, we just have a couple more examples here. Our next one, f of x equals negative x squared plus 2x plus 8. So a for this one is negative 1, so it's opening down. And we want to find our x-intercepts. So we do that by finding f of x equals 0. So set this part of it equal to 0, negative x squared plus 2x plus 8 equals 0. Again, I don't like my x squared to be negative, so I'm going to factor out a negative 1. That'll give me x squared minus 2x minus 8 inside the parentheses. And now we'll see if we can factor this. So can I factor a negative 8 so that the sum will give me negative 2, and we can. It would be x minus 4 and x plus 2. So negative 4 times positive 2 gives you negative 8, and negative 4 plus 2 gives you the negative 2 that we need. So my x-intercepts, setting x minus 4 equal to 0 will give us positive 4, and setting x plus 2 equal to 0 will give us negative 2. So our x-intercepts are at 4, 0 and negative 2, 0. Now I'm going to write this function back down on the bottom of our graph here, so that we can see it for the rest of our work. And we want to find the y-intercepts. Again, that's at f of 0, which for this function will be 8. It's just always going to be that constant number. So our y-intercept is at the point 0, 8. And the last thing we need to find is our vertex. And the x-coordinate of our vertex is at negative b over 2a. So write that negative sign down. B is always the number in front of x squared, so that's a 2, divided by 2 times a, and a for this one is negative 1. So we get a positive 1. And the y-coordinate of our vertex is going to be at f of this number, 1. So again, I'm going to write my shell down. And then what we're going to put into our parentheses is that positive 1. So you got to be careful here. This negative sign is outside of this x being squared. So we're going to square the positive 1 and then multiply it by negative 1 afterwards. So this is positive 1 when we square the 1, but then negative because of this negative sign here. So we get negative 1 plus 2 plus 8. And that gives us 10 minus 1, which is 9. So our vertex is at the point 1, 9. Now we'll put all this information onto our graph. So my vertex is at the point 1, 9, which is 1 unit above my graph here. And this parabola is opening down. And we can use the pattern on this one. We would go right 1, down 1. And left 1, down 1, and then right 1, down 3, and then left 1, down 3. And we also need to have on there our x-intercepts. We have our y-intercept already, but we need our x-intercepts, which we're at 4, 0, and at negative 2, 0. So let's label the rest of our points. We have 2, 8, 3, 5, 0, 4, oops, sorry, I did that backwards again, 4, 0, and negative 2, 0, and negative 1, 5, and 0, 8. And then we can draw our parabola in. And the domain, negative infinity to infinity for all parabolas. And then our range is, because it's opening down, it's going to start at negative infinity, and it goes up to the y-coordinate of the vertex, which is 9, and always a square bracket. One more example for this graphing of quadratic functions. We have f of x equals negative 1/2 x squared minus 2. So again, a for this one is negative 1/2, and so this is less than 0, which means it's opening down. We want to find our x-intercepts, and to find x-intercepts we set our function equal to 0, so negative 1/2 x squared minus 2 equals 0. This one I'm not going to try to factor because I have this x squared term but no x term, and so that means that I can add this 2 to both sides of the equation, and it'll give me negative 1/2 x squared equals 2, and then multiply both sides by negative 2. So let me just... So now, positive 2 times a negative 1/2 gives us, oops, that should be a negative 2, sorry, because we want positive x squared. So this will give me a positive 1, so that'll leave me with x squared. And on the other side I get negative 4. And then take the square root on both sides, and that gives us x equals plus or minus 2i. So this is not a real number. And so what that tells me is that there are no x-intercepts. Okay. And then we want our y-intercepts. And I'll just write our function back down on the bottom of the graph here. Negative 1/2 x squared minus 2. And so when we plug 0 into this function, we'll be left with this constant term, which is negative 2. So our y-intercept is at 0, negative 2. Now we want to find the vertex. The x-coordinate of the vertex is at negative b over 2a. So write your negative sign down. B for this one is, it's always the number right in front of x, and this one does not have an x, so that means that B is 0. And then 2 times a, and a is always the number in front of x squared, which is negative 1/2. So we have a negative sign, and then we have 0 divided by negative 1, and 0 divided by anything is 0. So our vertex, x-coordinate of our vertex is 0. So for the y-coordinate, we want to find f of 0. And for this one, that was negative 2. So our y-intercept and our vertex are the same thing. So 0, negative 2 is my vertex. It's also my y-intercept. This parabola is opening down and the vertex is below the x-axis, and so that means that it never crosses the x-axis. That's why we got this negative number underneath our square root, which tells me that there are no x-intercepts for this graph. So luckily it's the vertex is something nice, so we can use our pattern. And so the pattern says go right one down by a, so we're going to go right one down 1/2 and left one down 1/2. And then from those 2 points, we go right one down 1.5. And then from this point right here, go left one and down 1.5 again. And then I need to label my points. So I have the point 1, and then this point is negative 2 1/2. And then we have 2, 4, negative 4. And then we have the point negative 1, negative 2.5, and the point negative 2, negative 4. Okay, and then we need our domain, negative infinity to infinity, and our range. So again, this one's opening down, so it's from negative infinity up to the y-coordinate of the vertex, which is negative 2, and you use a square bracket. All right, so that is the end of this lecture on graphing quadratic equations or quadratic functions. So if you have any questions, just let me know. Thanks.